So when it comes to resiliency, one of the most important things to worry about is data redundancy and recovery. So in most cases, API servers are stateless, which means that a lot of API servers are put behind a load balancer. Request can go to any one of them, right? And even if one of the API server goes down, it's fine. Other API servers can handle the request. Only the requests that are in transit are affected, right? So this is very simple when it comes to stateless API servers. But what about databases? Databases are stateful because they hold the data. If the database goes down, in most cases, it is a complete outage. The worst thing that would happen is if your database crashes such that your disk crashed and you have loss of data. A good system, whenever you design, always takes care of this catastrophic situation that you have, that hey, I don't have data anymore. What do you do with that? So you just cannot say, oh my god, my database crashed, I don't have any data backup with me. So there are ways to solve it. Always remember, whenever it's about data, like whenever you want to make your data side of things resilient, first thing that should come to your mind is redundancy. Can I make my data redundant? When you make your data redundant, basically creating multiple copies of your data. Once you make your data redundant or create multiple copies of your data, it helps you recover your database to last known good point, right? And that's really important. Now in this one, we'll talk about data redundancy and multiple ways to achieve that. First thing, redundancy can be implemented. So here when I say redundancy, it is redundancy of data. Now redundancy can be implemented at multiple levels. For example, row level or document level. So if you are having MySQL DB, you can replicate rows across databases, right? Or you can say, I'll replicate tables. Like you dump the table and create different table, right? You dump the database, create other database, right? So redundancy, it's up to you at what level you'd want to create, right? We'll start with simple and then make things complicated. So let's start with the first one. Backup and restore, right? It's the simplest way to prepare yourself for an outage or for a massive catastrophic situation, right? So what you do daily incremental backup of data. For example, you do a complete backup once and whatever changes have been made in one day, you dump it. And for every day you repeat this, right? This is your daily backup of data, which means in case there is a catastrophic situation today, you would have your data up until yesterday. It's better to have some data rather than nothing, right? So you can restore it to your yesterday's point and you still have something around your business or your product up and running. Second is you do weekly complete backups of your database. So every week, let's say every Sunday, you run a complete backup of your database no matter what, right? So even if some of your incremental things are incorrect, inconsistent, whatnot, a complete backup would ensure that you have some good point to record to go to, right? You can restore that point and have your business up and running. Third is more important, where you store one copy across region for disaster recovery. Now, natural calamities happen. What is the worst thing that would happen? Let's say an entire data center submerged underwater and everything's gone. There is a major disaster that has happened where your data center was hosted. You cannot say, hey, my business cannot function, right? Which is where you store one copy of your data across data center. It's your responsibility to do, let's say, weekly copy of that data. Because you have data across data center, even if one data center is complete down, you have your data at other places and now you can serve it. Because that's what I say, data is stateful, API servers are typically stateless. So you can spin up API servers easily, but data is the oil, right? You don't want to lose that, right? So something goes wrong, you can always resort to the last backup and just get things up and running. It's one of the easiest way to get things done, right? Now this was one time kind of backup, right? But there is another concept called continuous redundancy. So here what you do is you don't just do backups like complete backups of database or daily backups of database. Here you are actively maintaining two copies of your data. You'll say, but how do I maintain it? A way to do it, set up replica of your database. Right? So you have your master node, you have your replica node. If master node goes down, data disk crashes, you have your replica there that can serve it. I'm not talking about normal outages. I'm talking about database crash. I'm talking about disk crashing, right? You cannot just say I don't have any data backup per se, right? So in case of continuous redundancy, what you are doing is you are ensuring that your data is continuously getting duplicated in another database, right? It's still not preventing from disaster recovery we talked about last point. This is about continuous redundancy, that if your database crashes, the disk of this database crashes, you have other database to resort to, right? You can just quickly spin up, like make this replica the master and start serving the data, right? This is a good way to ensure continuous redundancy. But now, how does this data, or how the data goes to replica? Two ways to do it. Either you do it asynchronously, where your replication is set up between your database and it is asynchronously copied, or you can have writes going to two databases, one to main, one to replica. Either way, the idea is to have real-time duplicate copies of your data, so you don't miss out on anything, right? And this depends. Some data is more critical than other. So more critical data is typically done continuous redundancy. Less critical data is typically backed up periodically, right? And this is how you think of redundancy. Just one point to cover on that. The replica that we think of over here is a standby machine. It may not be serving any user end traffic. All it is doing is it is just one standalone copy of your data which is continuously in sync with the master. That's it. It is not serving any read request, any write request, nothing. All its job is to ensure that there is another copy of data somewhere, right? So in case this goes down, this can take its place. When I say go down, it's complete crash. So you don't lose out on anything and your business continues to function, right? Okay. Now, as part of exercise, what I want all of you to do is set up replication between two MySQL servers. That's it. You need to know how to configure, how to spin up one database, spin up another database, make another database, follow the first database. You make the write, you see the write happening on another database automatically. Do that. Set up that asynchronous replication. Second, see how you can back up a MySQL DB. Third, from that backup, see how you can restore the database. When you do this practically, when you do these things hands-on, you would know much deeper on what are the challenges that would come in. You would know exactly what you need to do when you're setting up disaster recovery for your organization. When you're building actual practical production grade system, these are really the things that you should be looking out for, because this is what is ensuring that your business continues no matter what, right? So please get this thing done, implement this, have fun while implementing it. You'll have literally, I'm not even saying it, not even exaggerating it. The first time when I did it, I was so happy to understand how replication works, kind of commands that I would have to fire, how to backup DB, how to restore to the last checkpoint and whatnot. I really had quite some fun doing it, right? Highly recommend you to do that, right? And yeah, that's all what I wanted to cover in this one. I hope you found it interesting. Hope you found it amusing. I'll see you in the next one. Thanks for time.